Most of you know who I am, but for those of you who don't, I'm Professor Bumblebee, the headmaster for the school. And this, of course, is my phoenix, Falcus. I'd like to welcome you to this year's Museum of York County School of Witchcraft and Wizardry. But before we get started, I'd like to say a few words. Please be patient with the owl post, where your owls may run in a bit of delay delivering your kits and other pertinent information. We have found the need to stagger the delivery due to their volume, lest so many owls arise muggle suspicion. This year has brought some exciting changes to our program. In your kits, you'll find all the materials needed to complete your lessons with the professors. So, first of all, I'd like to introduce the professors and the lessons that they will be teaching. First of all, Professor Pistris will lead you in the study of potions and the chemistries behind them. But please note that the school will not be responsible for any experiments that have gone awry. Second of all, Professor Alphonse will lead you through the Alchemy class and instruct you in the growing of crystals. Professor Alphonse will lead you through your Alchemy class and instruct you in the growing of crystals. Miss Diomeda from the Ministry of Magic will take you on one of her scouting expeditions as she searches for a few of the best types of trees to create your wands. She'll also teach you how to use your tree guide. But before we get started, I'd like to bring you one last thought. Happiness can be found even in the darkness of time. But remember, turn on your light. Now, without further ado, grab your kit and your wand, and let's begin our program.
Hi everybody, I am Professor Pistris. I am the Potions Master here at the MYCO School of Witchcraft and Wizardry, and today I'm going to lead you through brewing a few potions. We're going to start out with a little bit of essence of jellyfish. We're going to take about 1/2 cup of the apple juice, or whatever kind of juice it is you're using. We're going to take about 1/4 of that and sprinkle the gelatin powder into it. We're going to take the rest of it and boil it. And we're going to mix our boiling juice into the mixture of chill juice and gelatin powder. And then we're going to stick that in the fridge for about 4 hours, and when it comes out, it will have solidified like so. Now, the way this works is that gelatin contains a protein called collagen. And when you stir it into the boiling juice, that collagen will both bond with the water molecules in that juice and also break apart a little bit. But then when you stir the chilled juice into the boiling juice, the collagen's bonds with the water molecules in that juice will actually get stronger, and it will slow down the molecules' movement as well. And that's how a liquid can become a solid. So next we're going to brew up some unicorn's bane, and for this...
So sorry to interrupt, Professor, but you know as High Inquisitor, it's my duty to evaluate the professors.
Sure.
Please continue.
Yes. Unicorn's bane. So for this potion, I'd like you to get out your lemon juice and your baking soda and a little bit of sugar if you've got that on hand. Now, lemon juice contains citric acid, which in turn contains carbon, hydrogen, and oxygen. Acids, by definition, are molecules that release a positively charged hydrogen atom, while the baking soda is the base and can release a negative molecule of hydrogen and oxygen atoms. So we are going to take about 1 teaspoon of that baking soda, and we are going to stir that into our 6 ounces of lemon juice and watch the reaction. Oh man. The citric acid in the lemon juice, as you can see, is reacting with the baking soda. This releases carbon dioxide, water, and sodium citrate. The carbon dioxide is what makes it fizz, and the sodium citrate and the water will remain in the liquid, which is our unicorn spain. And you may drink this. But make sure to add some sugar first. Our next potion, folks, is going to be a little bit of rainbow elixir. Now for this, we are going to take our candies here, and we're going to try and arrange them in a pretty colorful pattern like so. And next, we're going to take a little bit of water here, and we're going to pour that in just a little bit, cover a tiny bit of the bottom of the bowl like so. Now, the way this works is by a principle called diffusion, which refers to the tendency of molecules dissolved in water to move from an area of high concentration to one of low concentration. So since each one of these candies is producing the same amount of sugar dissolved in the water, the colors will move toward the center, but they will not mix.
Just one question. You've been at this post exactly how long?
A little over 3 years. So our final potion of the day is going to be some dragon oil. And for this, we're going to want to get out some water, our corn syrup, and vegetable oil. Now what we're going to do here is we are first going to take that corn syrup, going to pour a little bit of that into the water. We are then going to take our vegetable oil and do the same. And finally, a dab of food coloring. I like red. Now, what will happen when we put these three materials in there is that the syrup, the corn syrup, will sink to the bottom, while the vegetable oil will float to the top. This is because the vegetable oil has a lesser density than the water, while the corn syrup has a greater density. Density refers to the amount of material per area. Good way to think about it is if you took 2 cups of the same size and you filled one with a bunch of sugar and another with a bunch of popped popcorn kernels. Which one would be heavier? The sugar, right? That is because there is less area between the grains of sugar than between the kernels of popcorn. So it has a greater density than the popcorn. And that is exactly how the dragon oil works. I will warn you not to drink the dragon oil because it is not going to taste very good. And that ends our potions class for today. Hope you guys had fun, and I hope you learned something. You did a great job.
Might I see you in my office immediately after class, Professor?
Sure.
All right, everyone, settle. My name is Professor Alphonse. Welcome to an introduction to alchemy. Now, alchemy is a subject with a storied history stretching back thousands of years, and it gives us the modern foundation of our understanding of the world in ways you may not immediately recognize. Now, early alchemy, of course, was essentially a lot of burning, brewing, steeping, and stewing random chemical concoctions in pursuit of frankly impossible ends. But the methodology, the scientific method, and the foundations of modern chemistry can be found in those medieval laboratories, giving us the transition between a more symbolic understanding of the world to an evidence-based one. Now, for historical context, let's first examine this gentleman here. This is Philippus von Hohenheim, better known as Paracelsus. Paracelsus, renowned alchemist and early medical pioneer. He was one of the first, back in 1526, to demand that doctors had at least some general grounding understanding of science. He invented early painkiller medications. You may have heard the word laudanum before. And was one of the first to insist that wounds actually be cleaned. Prior to that, doctors thought that infection was a general, unavoidable part of the healing process. Many of these doctors also ascribed to the idea of spontaneous generation, where things like maggots would just be spawned out of rotting meat instead of flies being attracted and laying eggs. Now, Paracelsus, despite his advanced inclinations, was still interpreting his findings through symbology and his understanding of alchemy, grouping things into the reactions between salts as stand-ins for the physical body, the physical elements around us, sulfur representing the gaseous, and mercury representing the liquids. The interactions between these were part of the foundations of many of his discoveries. Now, not all historical alchemists have their reputation as well-founded, however. Nicholas Flamel's contributions, unfortunately, have been greatly exaggerated, as, of course, was his immortality. His reputation, as a matter of fact, didn't even come about until hundreds of years after his death. Now, part of the reason for that was related to his profession. Nicholas Flamel was a scribe, essentially tasked with copying contracts, important documents, and, for many alchemists, their research notes and formulae. Perhaps people looking back on him thought that his access to these normally kept very, very closely protected documents gave him insight that his contemporaries would have lacked, and that his, shall we call it, early onset peer review may have let him create things like the Philosopher's Stone, giving him the elixir of life and the ability to turn lead into gold. Highly overrated. Now, as I said, alchemy gives us much of our modern scientific foundation. The methodology used helped give rise to the scientific method, which is, of course, based on hypothesis leading to repeatable results. Once again, repeatable results. Unfortunately, a lot of purely magical work did not necessarily give us that kind of concrete evidence of the outcomes that many of these people purported to get. Many chemicals, even whole elements, have been discovered entirely by accident through these alchemists' machinations and laboratory findings. It comes down to a difference in understanding why those reactions were happening. Let's examine the case of Saturn's tree. Now, Saturn's tree was their word for these certain kinds of crystal formations. Now, what is a crystal? Well, a crystal is simply what we call it when the atoms in a material arrange themselves in a particular geometric form. That could be sugar, it could be salt, or in this case, lead. Lead is dissolved into solution, the liquid. And a metal, in this case zinc, is placed into it. Over time, you see crystals start to form on the zinc, what we call a single displacement reaction, where the lead in the solution, unseen to us, is being drawn out of that liquid and attracted and attached and growing in that structure on the metal, forming these crystals that look almost organic. They saw those crystals forming seemingly from nothing, much in the same way that you might observe a plant grow. Now, as mentioned before, many chemicals and even entire elements were discovered entirely by mistake. Happy accidents and byproducts of experiments into other things. And most of these are still used today, either in industry or even just around your own home. Things like zinc, phosphorus, refined carbon dioxide, all of these are byproducts of alchemical research still used today. All of these samples here on the table are results of alchemical research or later scientific development. We still use them all today. Copper, in particular these copper crystals, can be found in any electronics. Galena, derived from lead, is used in many batteries. We are seeing the results of hundreds of years of development around us every day. The difference is in our understanding, and again, the transition from symbology to evidence, and, as we said before, repeatable results. Now, as a clincher for our further understanding, let us examine this mineral here. This is asbestos, a silicate mineral that grows in long, thin strands of crystal, long fibers. Now, in the ancient world, it was discovered that asbestos is incredibly resistant to heat, fire, holds up very, very well, remarkably well. So, of course, found its way into various industries, various purposes. Unfortunately, the mining, refinement, and use of asbestos is extraordinarily toxic to humans, causing all manner of deadly disease over time. Thankfully, its use in the United States is mostly phased out, but it does unfortunately still see widespread use abroad, despite our knowledge of the side effects. Thankfully, fireproof materials, necessary as they are, have been developed that are safe for humans to be around. NASA sponsored development here in the Carolinas of a fiber that is used not only in spacesuits, but in firefighter uniforms nationwide. Now, as bright and white as this mineral is, and as relatively easy as it is to spin into textiles, this was sometimes made into clothing, most often for nobles. Why? Let us consider, before washing machines, before modern detergents, white cloth in particular was staggeringly difficult to keep looking clean. But an asbestos robe, for example, would need only be tossed on an open fire for the impurities to be burned away and the robe itself to be restored to its bright, white, pristine appearance, often in front of an adoring crowd. Often they would call this material salamander fur, named after Paracelsus's fire elemental salamanders. Now, of course, real salamanders have nothing particularly to do with fire, and they certainly don't have fur. But for more information on that, I will defer to another of our guests to further elucidate.
Hi, Newt Scamander here, also known as Ken Wagner, and we're going to talk a little bit about salamanders today. As you know, salamanders are amphibians, which means, like the frogs, part of their life is spent in the water, and they have to have moist skin. That's one way we can tell a salamander or an amphibian from a lizard. Lizards have dry, skaty skin. Salamanders and frogs have wet, slimy skin. I find salamanders to be very unique animals. I would say they're fantastic animals because they have some unique characteristics that other animals don't possess. Their mother salamander lays her eggs either in the water. I'll show you a salamander called a spotted salamander, which lays a jelly-like mass. If you're lucky enough to live near a pond in your neighborhood, you can look in the pond this time of year, early spring, and they go into ponds and lay these eggs and attach them to the various twigs and branches in the water. And then the mothers and the fathers disappear again. And where do they go? And these two salamanders I brought are called mole salamanders. One is the spotted salamander and there's a marbled salamander. They call them mole because they spend most of their life underground. Some of our early ancestors believed that salamanders were born of fire. Fire salamander, of course, comes to mind. That's an old world salamander. The fire salamander was hibernating in a pile of wood during the winter, and they would bring the wood in and, of course, put it on the fire, and the fire drove the salamander out. So they thought, well, the salamander had to be born from the fire. And the fire, actually, the salamander was just trying to get away, so he didn't want to get burned up. As we know nowadays, salamanders do not come from fire. They're not born of fire. They're born like all animals from eggs. Salamanders all lay eggs. All salamanders are carnivorous. They eat each other. They eat other small animals. They don't eat any plants. Another funny thing about a salamander is they have poisonous skin. That's why they're so important to us, is because their skin is so sensitive to outside influences. So if you notice a bunch of salamanders floating on the water or dying in your yard, they have come in contact with a poison, something that not only hurts them and kills them, but it can do the same to us. We'll start with the spotted salamanders. They're the ones that come out. If you want to see a spotted salamander in the wild, you probably got to go out in the middle of the winter or February when it's cold and it's raining and look in the small ponds, because the mother and fathers go there and they lay their eggs in a great big mass. It looks like jelly. And each little speck inside the jelly is a baby salamander in an egg, and it would develop into one of these. These are called not tadpoles. They look a lot like a tadpole. They're larvae. Salamanders have larvae. And they will grow up, and you will notice they have gills on them. They use the gills to get the oxygen they need out of the water. And if you leave a bunch of them together, you end up with usually one great big one because they eat each other. These come from marbled salamanders. Marbled salamanders are unique in the fact that they are very brightly colored. This one's a year old. This one's from last year. This was a baby I raised from one of these last year. As you can see, they're called marbled salamanders because they look like they're marbled. They don't like bright light. You'll never see a salamander out during the day. They come out after dark to hunt for their food, and they prefer to come out and do their hunting in the cooler part of the year, and also when it's damp out, even when it's raining out. They are unique animals in the fact that we don't see them during the summer. Why? They go underground. Remember, we call them mole salamanders. It's a family of salamanders that live underground most of the year, so you hardly ever see them. There's maybe, in a certain area, maybe thousands of them, but you don't see them because they're down underground. And you say, where do they go? Do they dig a hole? No, they go down in other animal holes, crayfish holes, under dead trees, down in the bottoms of dead trees and stuff. So that's how they survive the very, very hot weather. Remember, they're cool weather animals. They don't like heat at all. So the marbled salamander lays her eggs under a log or a rock in the fall of the year, and then she waits. She's there with them. She stays with them and protects them against things like ants, and she stays with them until it rains. And it rains and rains and rains, and it fills up her little place that she lives under the rock. And when it fills up, when the eggs are completely covered with water, they hatch. Mama's job is over. She leaves. She goes back underground. The baby salamanders, the eggs hatch, and then they have to go into the water like this and become larvae that live in there, and it depends on how warm the water is and how much food is in there before they become adult salamanders like these. The other salamander we're going to talk about is a little spotted salamander. These are very common. So that's the spotted salamander. The spotted salamander is different. She lays her eggs in the water. Remember, we talked in a big jelly-like mass. Mom and dad goes back down underground again, and they crawl off, and the babies are left on their own, and they hatch, and they end up looking just like this after they come out of their great big egg mass, and then they grow in the water, and this is full grown. Incidentally, the largest salamander in the world is called a Japanese salamander, and they, believe it or not, get up to 5 foot long. And then the third largest salamander in the world is the hellbender, which is a funny sounding name. Hellbenders are known to be in the United States. And the hellbender, they are funny looking salamanders. They spend their entire life in the water under big flat rocks. They have to have fast moving, very cold water, and they're also endangered right now. They're protected completely in the United States. We'll let the salamander back in his little pen there.
Spot, where are you? Where have you been?
Oh my goodness, Hagrid!
Well, hello there, miss.
Oh my, I haven't seen you since my school days. How are you?
I'm doing fine, and you?
Oh, doing great. I'm working for the ministry now, and I'm looking for special trees to make wands. So, what are you doing here?
I'm just looking for some invasive plants. You know, you don't want them to take hold.
Oh, I know. They're awful. You know, I was back there, and I saw some privet. You might want to check that out.
Oh, well, check it out, ma'am.
Yeah,
Yes, I will.
Yeah, sounds great. Hey, Hagrid, have you seen a pear tree anywhere around?
Oh, yes, I have. If you go back down here to the big rock
Oh.
and take a left, it'll be down there.
Oh, thank you. I must have just missed it. Thank you so
You're
much.
quite welcome.
So good to see
You
you,
too, miss.
Hagrid.
Take care. Spot, you almost got us in trouble.
I turned at the rock. Well, maybe Hagrid had it wrong. Well, there's the Nellis pear. I finally found it. Hi, everyone. My name is Diomeda, and I'm from the Ministry of Magic. I'm looking for wood that can be used in wand making. Now, wood is what we call a natural resource. A natural resource is anything that makes the lives of muggles and witches and wizards easier. The Nellis pear tree was brought here from Belgium in 1823. It was a really popular pear tree because the pears it produced are really crunchy and hard and last a really long time, so they were good for preservation or for preserves. Our Nellis pear was found on an old homestead, and that is one way you could tell if an area had an old homestead, is if you find these old types of trees that aren't very popular anymore, but were popular a long time ago. Today, pear trees are popular because they have a really pretty wood, so muggles and witches and wizards, they like to use them in woodworking projects such as dining room tables, chest of drawers. In wand making, the golden toned wood produces wands of splendid magical powers, which give of their best in the hands of the warm-hearted, the generous, and the wise. I'm using the familiar trees of South Carolina to help me identify some of the trees that I'm specifically looking for. You can download it for yourself from Clemson Extension. In my book, I'm going to turn to page 4. And there is a little description here of this shortleaf pine. When you're looking for a shortleaf pine tree, you want to look for needles that have 3 little needles or 2 little needles. It's also beneficial to look way up because, as you can see on this tree, the branches are all the way up there. But one easy way to tell is to look for the cones, because shortleaf pines will hold onto their cones until they disintegrate. This is an eastern red cedar. When you look for eastern red cedar, look for bark that is stringy and kind of peeling. The foliage is also kind of sharp and prickly. An eastern red cedar can live for hundreds of years, and they were popular in the past and still today as Christmas trees. Whenever I meet one who carries a cedar wand, I find strength of character and unusual loyalty. So this is the holly tree. Hollies have evergreen leaves with prickles on the leaves here. Hollies have male and female trees. Both of them will flower, but only the females will produce berries. So that's how we know that this particular holly is a male holly, because there are no berries. Holly is one of the rarer kinds of wandwoods. Traditionally considered protective, it works most happily for those who may need help overcoming a tendency to anger. Here is a black walnut tree. Black walnut trees, if they're growing out in the open like this one is, can reach 75 feet tall. The wood is actually the most expensive wood that you can buy in North America, because it is so prized for its color and the grainy wood that looks wonderful in cabinet making. The fruit, the black walnut fruit, has a fruit inside, which of course is the walnuts that we probably snack on every now and again, but it also can make a good ink or dye. The black walnut wand will seek a master of good instinct and powerful insight.
Welcome to Harry Potter Science Day. There are many characters in the Harry Potter series of books that are named after real stars or constellations in the sky, including practically the entire Black family. We'll be looking at just 7 of them, all of which you can see in the Carolina skies tonight, if it's clear. Here we have tonight's sky as seen from the Carolina Piedmont at 10 p.m. facing southwest. I am using the free planetarium program Stellarium to show you the sky. It's not as good as the real sky or the planetarium sky, but it will have to do. Let me give you some clues as to the first person I will talk about. See if you can guess his name. He is Harry Potter's godfather. He was sorted into the house of Gryffindor. He could change himself into a black dog. He spent time in Azkaban prison. And the answer is Sirius Black. Sirius is the name of the brightest star in the nighttime sky. If you are good at looking at stars and judging their brightness, you can point it right out. It is high in the south in the evening sky in late winter. See if you can find it. It's right over here. I'm not all that good at judging which star is the brightest. They all look about the same to me. That's why I have a second method for finding Sirius. I first find the belt of Orion. Look for 3 stars in a line that are equal in brightness, about a pinky's width apart. They are surrounded by 4 stars in a rectangle, so that the full shape looks like a butterfly or bow tie in the sky. See if you can find it. Here are the 3 belt stars. And here is the Orion shape. According to his myth, Orion was the bravest hunter who ever lived. Once I locate the 3 belt stars in Orion's belt, I follow them down and to the left, and that is how I find Sirius. Sirius is an ordinary star, a little hotter than the sun. It is a white star, while our sun is a yellow star. Sirius is so bright because it is one of our nearest star neighbors, only 8.6 light years away, which is really close for a star. Sirius is the brightest star in the constellation of Canis Major, the large dog. Canis Major was one of Orion's 2 hunting dogs. It does make sense that Sirius Black could change himself into a dog. See if you can guess the name of our next Harry Potter character. She also spent time in Azkaban prison. She was the cousin of Sirius Black. After graduating from Hogwarts, she became a Death Eater. Bellatrix Lestrange. Bellatrix is a star in the constellation of Orion. If we look at the constellation of Orion again, these 2 stars represent his shoulders, and these 2 represent his feet. This star at his left shoulder is named Bellatrix. The word Bellatrix means female warrior in Latin. This star is sometimes called the Amazon star. Bellatrix is a blue star, one of the hotter stars that we can see, and is 240 light years away. This next one is a bit tougher. She was a character in the books but did not appear in the movies. She gave birth to a son at a Muggle orphanage. She died after naming him Tom. Her name is Merope Gaunt Riddle. To find Merope, I start once again from the belt of Orion, only this time I follow it up and to the right to this bright star, which marks the eye of Taurus the bull. Taurus appears to be attacking Orion the hunter. Only the head, neck, and back of the bull are shown. Riding on the back of the bull is this little cluster here. It looks kind of like a tiny dipper, but it is not the Little Dipper. This group of stars goes by different names, but most people in the United States call them the Pleiades or Seven Sisters. Let's zoom in on the Pleiades. Through a time exposure photograph, you can see that there are over 100 stars here. This one is Merope. Merope is the 4th brightest of the Pleiades. All of the Pleiades stars are blue-white in color and about 100 million years old. Merope is famous for the cloud of dusty gas that surrounds it, called the Merope Nebula. According to the ancient Greek myth, Merope was the youngest of the 7 sisters and the only one to marry a mortal. According to the myth, she hid herself in shame, and the star faded away from its former brilliance. Ready for the next person? She is absent-minded and has unconventional patterns of thought. She was sorted into the house of Ravenclaw. Her nickname is Loony. It's Ravenclaw student Luna Lovegood. Luna is another name for the moon. Words like lunacy and lunatic come from the word luna. Tonight, February 20th, the moon is just past first quarter, a phase called gibbous. The moon changes its shape and position every night as it orbits Earth once each month. Tonight and tomorrow, the moon is in the constellation of Taurus the bull. Tonight it is located between the horns of the bull, but by tomorrow night it will have moved to a place above them. We don't meet this next gentleman directly in the books or movies, but we hear about him. Here are a few hints to his identity. He was the younger and more beloved brother of Sirius Black. It turned out that he was stronger, braver, and more like his brother than anyone knew. That's right, it's Regulus Black. The star Regulus is in the evening sky in springtime. In February, it rises in the east during the night. We need to face east to see it. Regulus is at the heart of the constellation of Leo the Lion, and the heart of the lion would be a fitting name for Regulus Black. Also, a lion is the sign of the house of Gryffindor. To find Regulus and Leo, I start with the Big Dipper. When the Big Dipper is high in the sky, I know that Leo will be too. The Big Dipper is low in the northeast. To find Regulus and Leo, I start with the Big Dipper. When the Big Dipper is high in the sky, I know that Leo will be too. The Big Dipper is low in the northeast in the sky tonight. See if you can find it. It looks like a saucepan or shopping buggy in the sky. Here's a hint. This is the star at the end of the handle. The Big Dipper is part of a larger constellation known as the Great Bear. You can see the dipper shape as the hips and tail of the bear. Once I find the Big Dipper, I pretend that the dipper is a saucepan and that there is a hole in its bottom. The water escapes through the hole and runs out towards the back of Leo the Lion. Leo is basically a backwards question mark called the sickle and a triangle which makes up his rear end and tail. This bright star is the lion's heart, Regulus. The name Regulus is Latin for little king because the lion is the king of the animals. Regulus is a bluish white star that is 77 light years away. The next person is not so well known. He was Sirius Black's uncle. He left his money to Sirius. He was disowned by the Black family. His name was Alphard Black. The word Alphard means the solitary one in ancient Arabic. Perhaps his name is fitting because he was disowned. The star Alphard is in the constellation of Hydra, the water snake. Interestingly, Alphard Black was a student in the House of Slytherin. Alphard marks the heart of the snake and dominates this rather dim constellation. The star is an orange giant star about 175 light years away and is surprisingly bright and dominant in this dim area of the sky. I am now moving the sky, so we are facing north. This last gentleman needs no introduction. He is a Slytherin student. He does not get along at all with Harry Potter. He eventually married Astoria Greengrass and had a son named Scorpius, Draco Malfoy. To find Draco, I start first by locating the Big Dipper. It's something I find by shape alone. Do you remember where it is? The sky's a bit different now since we are facing north. Once I find the Big Dipper, I follow these two stars called the pointer stars, Merak and Dubby, and I go about 5 times their distance apart to locate Polaris, also known as the North Star. It's not as bright as most people think. The North Star is at the end of the handle of the Little Dipper, which is also not as bright as people think it should be. Draco starts between the Dipper, wraps around the bowl of the Little Dipper, and then the opposite way, and then his head wraps around here. While Polaris is the North Star to us, at the time the Great Pyramid of Egypt was built, One of the stars in Draco, Thuban, was the North Star, and one of the shafts of the Great Pyramid points to it. The position of the North Star changes due to the 26,000-year wobble that Earth's axis makes. So the constellation Draco was an important one long ago, but today, not so much. I hope that you enjoyed today's presentation, and I hope that I convinced you that J.K. Rowling didn't pick the names of her characters as she did by accident. Go outside tonight and point out these Harry Potter objects to someone else to share with them a greater appreciation of the night sky.
Now that you've completed your lessons, you are part of the Deathly Hallows. So have all power, hide from death, and live forever. And you are now a master of wizardry.